Question 1. To address the challenge of a building renovation project potentially disturbing asbestos-containing materials, ACM, in an older facility, what is the most appropriate initial course of action for a registered environmental, safety and health manager, REHS/RS, to ensure compliance with applicable environmental and occupational health regulations? Option A. Engage a certified asbestos inspector to conduct a comprehensive asbestos survey of the renovation areas and develop an abatement plan if ACMs are identified, prior to any disturbance. Option B. Immediately begin the renovation work while informing workers verbally about the potential presence of asbestos and advising them to be cautious. Option C. Rely on visual inspection by the site supervisor to identify any materials that appear to be asbestos and instruct workers to avoid those areas. Option D. Proceed with the renovation, assuming no asbestos is present unless a specific complaint is received from a worker. Correct answer is A. Engage a certified asbestos inspector to conduct a comprehensive asbestos survey of the renovation areas and develop an abatement plan if ACMs are identified, prior to any disturbance. Explanation. This scenario presents a professional challenge because the registered environmental, safety and health manager, REHS/RS, must balance the immediate need for operational efficiency with the long-term health and safety of workers and the public, particularly when dealing with known hazardous materials like asbestos. The REHS/RS is responsible for ensuring compliance with stringent regulations designed to prevent exposure to these hazards. The challenge lies in interpreting and applying complex regulatory requirements to a specific, potentially high-risk situation, requiring a deep understanding of the relevant legal framework and best practices. The correct approach involves a thorough, proactive, and compliant response that prioritizes hazard identification, risk assessment, and control measures in accordance with the specified regulatory framework. This approach is right because it directly addresses the potential for asbestos exposure by initiating a comprehensive survey and abatement plan, which aligns with the precautionary principle embedded in environmental and occupational health regulations. Specifically, it adheres to the principles of hazard communication, exposure monitoring, and the hierarchy of controls, ensuring that any identified asbestos is managed safely and legally. This proactive stance minimizes the risk of worker exposure, potential long-term health consequences, and regulatory penalties. An incorrect approach that relies solely on visual inspection without professional assessment fails, because it bypasses the regulatory requirement for qualified personnel to identify and assess asbestos-containing materials (ACM). Asbestos fibers are microscopic and not reliably detectable by sight alone, leading to a false sense of security and potential for significant exposure. This approach violates regulations mandating specific inspection protocols and the use of certified professionals for asbestos surveys. Another incorrect approach that involves immediate removal without proper planning and containment is professionally unacceptable because it disregards the critical need for a phased abatement process. Improper removal can aerosolize asbestos fibers, leading to widespread contamination and severe health risks to workers and building occupants. This violates regulations concerning controlled demolition, waste management, and personal protective equipment, and can result in significant legal liabilities and public health crises. A third incorrect approach that focuses only on informing workers of potential hazards without implementing control measures is insufficient. While hazard communication is a regulatory requirement, it is only one component of a comprehensive safety program. Simply informing workers about the presence of potential asbestos does not eliminate the risk of exposure. Regulations mandate the implementation of specific control measures, such as engineering controls, administrative controls, and personal protective equipment, to reduce exposure to acceptable levels. The professional decision-making process for similar situations should involve a systematic approach. 1. Identify the potential hazard in its regulatory context. 2. Consult the relevant regulatory framework, e.g., OSHA standards for asbestos in the U.S., COSH in the UK, or equivalent local regulations. 3. Conduct a thorough risk assessment, which may require engaging qualified professionals for specialized testing. 4. Implement control measures based on the hierarchy of controls, prioritizing elimination and substitution, followed by engineering controls, administrative controls, and finally, personal protective equipment. 5. Ensure proper training, hazard communication, and record keeping. 6. Regularly review and update safety protocols based on new information or changes in operations. Question 2. Analysis of a situation where a new chemical processing unit has undergone a job hazard analysis, JHA, and a hazard and operability HAZOP study, identifying several potential risks. The project manager is pushing for immediate startup to meet a critical market demand, suggesting that the findings from the JHA and HAZOP are sufficient, and a formal pre-startup safety review, PSSR, can be deferred. As the Registered Environmental Safety and Health Manager, REHS/RS, what is the most appropriate course of action, adhering strictly to U.S. regulatory frameworks and professional ethical standards? Option A. Conduct a comprehensive pre-startup safety review, PSSR, that integrates the findings from the JHA and HAZOP, ensuring all identified hazards are adequately controlled before startup. Option B. Rely solely on the HAZOP study's recommendations, assuming they cover all necessary safety aspects, and bypass the formal PSSR process. Option C. Proceed with startup based on the project manager's assurance that the JHA and HAZOP findings are sufficient, and schedule the PSSR for a later date after operations have commenced. Option D. Delegate the PSSR to a junior safety technician, allowing the project manager to proceed with startup while the technician reviews the documentation. The correct answer is A. Conduct a comprehensive pre-startup safety review, PSSR, that integrates the findings from the JHA and HAZOP, ensuring all identified hazards are adequately controlled before startup. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for operational efficiency with the long-term imperative of ensuring worker safety and environmental protection. The pressure to meet production deadlines can create a conflict of interest, potentially leading to shortcuts in critical safety review processes. The REHS/RS must exercise sound professional judgment, prioritizing regulatory compliance and ethical responsibility over expediency. The correct approach involves conducting a thorough pre-startup safety review, PSSR, that specifically addresses the identified hazards from the job hazard analysis, JHA, and incorporates lessons learned from the HAZOP study. This approach is correct because it directly aligns with regulatory requirements for new or modified processes. The PSSR serves as a final verification step to ensure that all safety measures are in place and effective before operations commence. Ethically, it upholds the professional duty to protect workers and the environment by proactively mitigating risks. This systematic, multi-layered approach ensures that hazards are not only identified, but also systematically reviewed and controlled before potential exposure. An incorrect approach would be to rely solely on the JHA and bypass a formal PSSR. This is a regulatory failure because many regulations mandate a formal PSSR for new or modified equipment and processes. It is also an ethical failure as it skips a crucial verification step, potentially leaving unaddressed hazards in place. Another incorrect approach would be to proceed with operations based on the HAZOP study alone, assuming its findings are sufficient without a specific pre-startup verification. While HAZOP is a valuable hazard identification tool, it is not a substitute for a PSSR, which is designed to confirm that the recommendations from studies like HAZOP have been implemented and are functioning correctly. This represents a failure to adhere to established safety management system protocols and a disregard for the specific purpose of a PSSR. The professional decision-making process for similar situations should involve a clear understanding of regulatory mandates for each safety review process. JHA, HAZOP, PSSR. Professionals must recognize the distinct purpose and scope of each tool and ensure they are applied sequentially and appropriately. When faced with pressure to expedite operations, the REHS/RS should clearly communicate the regulatory and ethical implications of bypassing or inadequately performing any required safety review. Escalation to management, with clear documentation of risks and regulatory noncompliance, is a critical step if pressure to compromise safety persists. Question 3. The investigation demonstrates that air samples were collected for a specific airborne contaminant during a particular task. The analytical results indicate an average concentration below the established permissible exposure limit (PEL). However, observations during the sampling period noted significant variability in the task's execution, with some moments appearing to involve higher potential for contaminant release. Considering the principles of risk assessment and regulatory compliance for occupational exposure, what is the most appropriate next step for the registered environmental, safety, and health manager? Option A. Recommend a review of the sampling strategy to assess its representativeness of the full range of task variability and potential for peak exposures, and consider additional sampling if necessary. Option B. Inform the workers that the average exposure is below the PEL and that their current work practices are acceptable. Option C. Conclude that the PEL is not exceeded and no further action is required, as the average concentration is below the limit. Option D. Immediately implement engineering controls to reduce exposure, as the observed variability suggests a potential for exceeding the PEL at certain times. Correct answer is C. Conclude that the PEL is not exceeded and no further action is required, as the average concentration is below the limit. Explanation. The investigation demonstrates a common challenge in occupational health and safety, interpreting air sampling data in the context of regulatory limits and worker exposure. The professional challenge lies in accurately assessing risk, ensuring compliance with established permissible exposure limits, PEL, and recommending appropriate controls. This requires a nuanced understanding of sampling strategies, analytical methods, and the limitations of each. Careful judgment is needed to avoid over- or underestimating exposure, which could lead to inadequate protection for workers or unnecessary costly interventions. The correct approach involves a systematic evaluation of the sampling strategy's representativeness, the analytical method's suitability and accuracy, and the comparison of results against the relevant regulatory PELs. This approach is correct because it directly addresses the core objective of exposure assessment, determining if worker exposure exceeds legally mandated limits. Specifically, it requires verifying that the sampling duration and frequency adequately captured the potential for peak exposures and routine exposures, that the chosen sampling media and analytical method are appropriate for the specific contaminant and matrix, and that the results are interpreted in light of the established PELs, considering any applicable safety factors or guidance from regulatory bodies like OSHA, Occupational Safety and Health Administration, in the U.S. context. This aligns with the ethical and legal obligation to protect worker health and safety. An incorrect approach that relies solely on a single grab sample, without considering the variability of the work process or potential for higher exposures, fails to meet the regulatory requirement for representative sampling. This is a regulatory failure because OSHA standards, for example, often require sampling strategies that account for the full range of exposure conditions. Another incorrect approach that uses an analytical method not validated for the specific contaminant or matrix introduces uncertainty and can lead to inaccurate exposure data, a failure in both regulatory compliance and professional due diligence. Furthermore, interpreting results without reference to the established PELs or using outdated or inappropriate reference values is a critical regulatory and ethical failure, as it negates the purpose of the assessment and potentially leaves workers exposed to hazardous conditions. The professional decision-making process for similar situations should involve a thorough review of the sampling plan, the analytical report, and the applicable regulatory standards. Professionals must critically evaluate the data's quality and representativeness, consider the specific work tasks and potential exposure scenarios, and always benchmark findings against the relevant PELs. If any aspect of the sampling or analysis is questionable, or if the results are borderline, further investigation or more robust sampling strategies should be implemented to ensure worker protection and regulatory compliance. Question 4. During the evaluation of a new assembly line process, you observe that several workers are frequently shifting their postures, rubbing their necks, and reporting mild discomfort in their wrists and shoulders after a few hours of work. The production supervisor is concerned about any changes that might slow down the assembly rate, which has recently been optimized. Which of the following approaches best addresses the potential ergonomic risks in this scenario? Option A. Advise the production supervisor that since there are no reported injuries, the current discomfort is likely minor and will resolve with time, and no immediate action is necessary. Option B. Suggest that employees simply take more frequent short breaks on their own initiative to alleviate discomfort, without formalizing a break schedule or assessing the workstation. Option C. Conduct a detailed ergonomic assessment of the workstation and tasks, involving observation, measurement of postures and forces, and employee interviews to identify specific risk factors and recommend targeted interventions such as workstation adjustments, tool modifications, or task rotation. Option D. Focus solely on the supervisor's concern for production speed, assuring them that the observed discomfort is a normal part of demanding work and does not warrant any changes to the current process. The correct answer is C. Conduct a detailed ergonomic assessment of the workstation and tasks, involving observation, measurement of postures and forces, and employee interviews, to identify specific risk factors and recommend targeted interventions such as workstation adjustments, tool modifications, or task rotation. Explanation. This scenario presents a common challenge for an environmental, safety, and health REHS manager, balancing the need for efficient workflow with the imperative to protect employee well-being. The professional challenge lies in identifying and mitigating ergonomic risks that are not immediately obvious or are perceived as minor by management, especially when productivity is a primary concern. Careful judgment is required to advocate for changes that may have initial costs or perceived disruptions, but are essential for long-term health and safety compliance. The correct approach involves a systematic, data-driven assessment of the workstation and tasks, followed by the implementation of evidence-based ergonomic interventions. This aligns with the fundamental principles of occupational safety and health management, which mandate employers to provide a safe working environment and prevent work-related injuries. Specifically, regulatory frameworks like OSHA General Duty Clause, 29 CFR 1910, 1450, require employers to protect employees from recognized hazards that are causing or are likely to cause death or serious physical harm. Ergonomic hazards, when identified and unaddressed, fall under this clause. Ethical considerations also demand proactive measures to safeguard employee health. An incorrect approach that focuses solely on immediate productivity without addressing the identified ergonomic risks fails to meet regulatory obligations. This demonstrates a disregard for the employer's responsibility to provide a safe workplace and can lead to citations, fines, and increased workers' compensation claims. It also represents an ethical failure to prioritize employee well-being. Another incorrect approach that relies on anecdotal evidence or employee complaints without a formal ergonomic assessment is insufficient. While employee feedback is valuable, a structured evaluation is necessary to objectively identify the root causes of ergonomic discomfort and to design effective solutions. This approach risks overlooking critical risk factors or implementing ineffective solutions, leaving employees vulnerable to injury. A third incorrect approach that dismisses the need for intervention due to perceived low risk or cost is professionally unacceptable. The absence of reported injuries does not equate to the absence of risk. Proactive risk assessment and mitigation are key to preventing future incidents. Ignoring potential hazards based on cost or current incident rates is a failure of due diligence and can have severe consequences. The professional decision-making process for similar situations should involve 1. Recognizing potential hazards through observation, employee feedback, and established ergonomic principles. 2. Conducting a thorough risk assessment using appropriate tools and methodologies. 3. Prioritizing interventions based on the severity of the risk and potential for injury. 4. Implementing evidence-based solutions, which may include engineering controls, administrative controls, and personal protective equipment. 5. Evaluating the effectiveness of implemented controls and making adjustments as needed. 6. Documenting all assessments, interventions, and evaluations. Question 5. Strategic planning requires a comprehensive evaluation of radiation control measures in a manufacturing facility that utilizes both X-ray inspection equipment non-ionizing and a small, sealed radioactive source for calibration purposes ionizing. Which of the following approaches represents the most effective and compliant strategy for managing radiation exposure risks? Option A. Implement personal protective equipment, such as lead aprons and dosimeters, for all personnel working in proximity to the radiation sources. Option B. Prioritize engineering controls such as shielding and ventilation, supplemented by administrative controls like work procedures and access restrictions, with personal protective equipment used only when these are insufficient. Option C. Concentrate efforts on ensuring that all radiation exposures remain below the maximum permissible dose limits, without actively pursuing further reductions. Option D. Focus on selecting the least expensive control measures that ensure compliance with the established regulatory dose limits for both types of radiation. The correct answer is B. Prioritize engineering controls such as shielding and ventilation, supplemented by administrative controls like work procedures and access restrictions, with personal protective equipment used only when these are insufficient. Explanation. Scenario analysis. This scenario presents a professional challenge for an REHS/RES by requiring the evaluation of different radiation control strategies in a workplace setting. The challenge lies in balancing the need for effective radiation protection with practical implementation, cost-effectiveness, and adherence to regulatory requirements. A key difficulty is discerning which approach best aligns with the principles of ALARA, as low as reasonably achievable, and the specific mandates of the relevant U.S. regulatory framework, which often involves nuanced interpretations of dose limits and exposure reduction techniques. Careful judgment is required to select a strategy that is not only compliant, but also demonstrably protective of worker health and safety. Correct approach analysis. The correct approach involves a comprehensive risk assessment that prioritizes engineering controls, followed by administrative controls, and finally, personal protective equipment (PPE) as a last resort. This hierarchy of controls is a fundamental principle in occupational safety and health, deeply embedded in U.S. regulations such as those promulgated by OSHA, Occupational Safety and Health Administration, and NRC, Nuclear Regulatory Commission, where applicable. Specifically, OSHA General Duty Clause and various standards related to ionizing and non-ionizing radiation mandate employers to provide a workplace free from recognized hazards. Prioritizing engineering controls, e.g., shielding, ventilation directly addresses the source of radiation. Administrative controls, e.g., work procedures, time limitations, reduce exposure duration, and PPE serves as a final barrier. This systematic layered approach ensures that radiation exposure is minimized to levels as low as reasonably achievable ALARA, aligning with both regulatory intent and ethical responsibility. Incorrect approaches analysis, relying solely on personal protective equipment, PPE, as the primary control measure is a regulatory and ethical failure. While PPE can offer protection, it is considered the least effective control method because it does not eliminate or reduce the hazard at its source. U.S. regulations generally mandate that PPE be used only when engineering and administrative controls are not feasible or are insufficient to reduce exposure to acceptable levels. This approach fails to meet the ALARA principle and the employer's responsibility to implement more robust controls. Implementing controls based solely on cost-effectiveness without a thorough risk assessment or consideration of the hierarchy of controls is also a failure. While economic factors are a consideration in practical implementation, they cannot supersede the primary regulatory obligation to protect worker health. A cheaper solution that offers inadequate protection is not a compliant or ethical choice. This approach risks violating OSHA standards and potentially leading to overexposure and health consequences for workers. Focusing exclusively on meeting the minimum regulatory dose limits without striving for ALARA is another incorrect approach. U.S. regulations, particularly those from the NRC for licensed materials and OSHA for other sources, often emphasize the ALARA principle. Simply staying below the legal limit does not fulfill the obligation to reduce exposures as much as is reasonably achievable, which is a cornerstone of radiation safety. This approach may be compliant on paper, but fails to demonstrate best professional practice and proactive risk management. Professional reasoning. Professionals should adopt a decision-making framework that begins with a thorough hazard identification and risk assessment specific to the types of radiation present and the work activities involved. This assessment should then inform the selection of control measures, strictly adhering to the hierarchy of controls: elimination/substitution, engineering controls, administrative controls, and finally, PPE. Continuous monitoring, record keeping, and periodic review of control effectiveness are essential to ensure ongoing compliance and worker protection. When evaluating options, the primary consideration must always be the health and safety of individuals, guided by the ALARA principle and specific U.S. regulatory requirements. Question 6. The risk matrix shows a high likelihood and significant consequence for mold and moisture issues in a newly acquired commercial building. As the registered Environmental, Safety and Health Manager, REHS/RS, which of the following approaches best addresses this identified risk, considering the need for regulatory compliance and occupant well-being. Option A. Implement a comprehensive remediation plan that includes containment of affected areas, professional removal of contaminated materials, identification and repair of moisture sources, and establishment of ongoing monitoring and preventative maintenance protocols. Option B. Conduct superficial cleaning of visible mold growth in affected areas and advise occupants to ventilate the spaces thoroughly. Option C. Provide occupants with basic instructions on how to clean small mold patches themselves and recommend the use of household cleaning products. Option D. Immediately initiate extensive demolition and reconstruction of all potentially affected areas without prior containment or detailed assessment. The correct answer is A. Implement a comprehensive remediation plan that includes containment of affected areas, professional removal of contaminated materials, identification and repair of moisture sources, and establishment of ongoing monitoring and preventative maintenance protocols. Explanation: the risk matrix shows a high likelihood and significant consequence for mold and moisture issues in a newly acquired commercial building. This scenario is professionally challenging because it requires a proactive and comprehensive approach to environmental health and safety, balancing immediate remediation needs with long-term prevention and regulatory compliance. The REHS/RES must not only identify the immediate hazards, but also understand the underlying causes and implement sustainable solutions. The correct approach involves a thorough, multifaceted strategy that prioritizes containment, source identification, and professional remediation, followed by robust preventative measures. This aligns with the principles of responsible environmental management and public health protection mandated by regulatory frameworks. Specifically, it addresses the immediate threat to occupant health and safety by preventing the spread of mold spores and addressing the moisture intrusion. The emphasis on professional remediation ensures that the work is performed according to established standards, minimizing further contamination and health risks. Furthermore, the inclusion of ongoing monitoring and preventative maintenance is crucial for long-term compliance and occupant well-being, reflecting a commitment to best practices beyond mere superficial fixes. An incorrect approach that focuses solely on superficial cleaning without addressing the moisture source fails to meet regulatory requirements for hazard control. This approach neglects the fundamental principle that mold growth is a symptom of a larger problem. Without eliminating the moisture, mold will inevitably return, posing a continuous health risk and potentially leading to structural damage, violating the duty to provide a safe and healthy environment. Another incorrect approach that involves immediate demolition and reconstruction without proper containment and assessment is also professionally unacceptable. This can lead to the uncontrolled release of mold spores into unaffected areas, creating a larger contamination problem and exposing workers and occupants to higher levels of airborne mold. It also represents a failure to follow established remediation protocols, which typically involve containment, HEPA filtration, and controlled removal of contaminated materials. A third incorrect approach that relies on occupant self-remediation without proper guidance or assessment is a significant ethical and regulatory failure. This places an undue burden on individuals who may lack the knowledge, equipment, or protective measures necessary to safely handle mold contamination. It also abdicates the responsibility of the REHS/RES to ensure a safe environment, potentially leading to inadequate remediation and continued health issues for occupants. Professional decision-making in such situations requires a systematic process. First, a thorough assessment of the extent and nature of the mold and moisture problem. Second, identification of the root cause of moisture intrusion. Third, development of a remediation plan that adheres to recognized industry standards and regulatory guidelines. Fourth, implementation of the plan with appropriate containment and personal protective equipment. Fifth, verification of successful remediation through post-remediation testing. And finally, establishment of preventative measures to avoid recurrence. This structured approach ensures that all aspects of the hazard are addressed, from immediate risk reduction to long-term sustainability and compliance. Question 7. Comparative studies suggest that a proactive, risk-based approach to indoor environmental quality, EQ management, is most effective. In a large office building experiencing a moderate increase in occupant complaints related to fatigue and headaches, which of the following implementation strategies would best align with the principles of effective IEQ management and regulatory compliance for a registered environmental safety and health manager, REHS/RS, operating under U.S. federal regulations. Option A. Rely on the building's existing maintenance logs and occupant feedback alone to make minor adjustments to the HVAC system, assuming the current system is adequate given its age. Option B. Focus solely on addressing individual occupant complaints by providing personal air purifiers and recommending lifestyle changes, as the complaints are varied and may not indicate a systemic issue. Option C. Conduct a comprehensive IEQ assessment, including air sampling for common pollutants, ventilation system evaluation, and a review of building operations to identify root causes and prioritize control measures based on risk. Option D. Immediately implement a building-wide air purification system, as it is a widely advertised solution for improving air quality, and address specific complaints as they arise. The correct answer is C. Conduct a comprehensive IEQ assessment, including air sampling for common pollutants, ventilation system evaluation, and a review of building operations to identify root causes and prioritize control measures based on risk. Explanation. This scenario presents a common implementation challenge for an REHS/RS, balancing the need for effective indoor environmental quality (EQ) management with the practical constraints of budget and stakeholder buy-in. The professional challenge lies in translating scientific understanding and regulatory requirements into actionable, cost-effective strategies that achieve desired health and safety outcomes. Careful judgment is required to prioritize interventions, communicate risks and benefits effectively, and ensure compliance without causing undue disruption or expense. The correct approach involves a systematic, risk-based strategy that prioritizes IEQ issues based on their potential impact on occupant health and regulatory compliance. This typically begins with a comprehensive assessment to identify potential sources of IEQ problems, followed by the implementation of control measures that address the root causes. This aligns with the principles of proactive environmental health management, emphasizing prevention and control as mandated by various environmental and occupational health regulations. For instance, under the Occupational Safety and Health Administration (OSHA) standards in the U.S., employers have a general duty to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. This implicitly includes maintaining acceptable indoor environmental quality. Furthermore, specific standards related to ventilation, air contaminants, and hazard communication would guide the assessment and control measures. Ethical considerations also demand that the REHS/RS advocate for the health and safety of occupants, which includes ensuring a healthy indoor environment. An incorrect approach that focuses solely on occupant complaints without a systematic investigation fails to address potential underlying issues that may not yet be apparent through complaints but still pose a risk. This reactive approach can lead to ineffective, piecemeal solutions and may miss significant IEQ hazards. It also risks violating regulatory requirements by not proactively identifying and mitigating hazards. Another incorrect approach that prioritizes the cheapest available solution without considering its effectiveness or long-term implications is a significant ethical and regulatory failure. Cost-cutting measures that compromise IEQ can lead to continued health problems, increased absenteeism, and potential legal liabilities. This approach disregards the employer's duty to provide a safe and healthy workplace and may violate specific standards that require effective control measures. A third incorrect approach that relies solely on anecdotal evidence or outdated guidelines overlooks current scientific understanding and regulatory updates. This can result in the implementation of ineffective strategies or the failure to address emerging IEQ concerns, thereby failing to meet the professional standard of care and potentially violating current regulations. The professional reasoning process for similar situations should involve a structured approach. 1. Identify the problem and its potential scope. 2. Gather information through a combination of data collection methods, including environmental monitoring, building system assessments, and occupant feedback. 3. Evaluate the risks associated with identified IEQ issues, considering potential health impacts and regulatory noncompliance. 4. Develop a prioritized action plan based on risk assessment, focusing on source control and effective mitigation strategies. 5. Implement control measures, ensuring they are effective and sustainable. 6. Monitor the effectiveness of implemented measures and make adjustments as needed. 7. Communicate findings, recommendations, and progress to relevant stakeholders. 8. Ensure all actions are compliant with applicable federal, state, and local regulations. Question 8. Market research demonstrates that a significant number of musculoskeletal injuries in a manufacturing facility are attributed to manual material handling tasks. As the Registered Environmental, Safety, and Health Manager, REHS/RS, you are tasked with developing a strategy to mitigate these risks. Which of the following approaches best aligns with regulatory requirements and professional best practices for addressing manual material handling hazards? Option A. Provide all employees with a one-time training session on general safe lifting principles and instruct them to report any discomfort experienced during material handling. Option B. Implement a comprehensive program that includes a thorough risk assessment of all manual lifting tasks, prioritizing the introduction of appropriate mechanical aids where feasible, followed by robust training on safe lifting techniques and work practices, and establishing a system for ongoing monitoring and feedback. Option C. Mandate the immediate purchase and deployment of various mechanical lifting devices across all departments without a prior assessment of specific task needs or employee training on their operation. Option D. Focus on individual employee responsibility by encouraging them to develop their own personal lifting strategies and to only report injuries after they have occurred. The correct answer is B. Implement a comprehensive program that includes a thorough risk assessment of all manual lifting tasks, prioritizing the introduction of appropriate mechanical aids where feasible, followed by robust training on safe lifting techniques and work practices, and establishing a system for ongoing monitoring and feedback. Explanation. This scenario is professionally challenging because it requires the REHS/RS to balance operational efficiency with the paramount duty of protecting worker health and safety, specifically concerning manual material handling. The challenge lies in identifying the most effective and compliant strategy for implementing safe lifting practices in a dynamic work environment where existing methods may be ingrained. Careful judgment is required to select an approach that is not only compliant with regulatory standards, but also practical and sustainable for the workforce. The correct approach involves a comprehensive assessment of the current manual material handling tasks, identifying specific risks, and then implementing a multifaceted strategy that includes engineering controls, mechanical aids, administrative controls, training, work rotation, and personal protective equipment where appropriate, all guided by regulatory requirements. This approach is right because it directly addresses the hierarchy of controls, prioritizing elimination or substitution of hazards through mechanical aids before relying on less effective measures. Specifically, regulations such as those promulgated by OSHA, Occupational Safety and Health Administration in the United States, particularly the General Duty Clause, Section 5(a)(1) of the OSH Act, mandate employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. Furthermore, OSHA guidance on manual lifting and the emphasis on ergonomic principles align with this comprehensive strategy. Ethically, the REHS/RS has a professional obligation to advocate for the safest possible working conditions, which includes proactively mitigating risks associated with manual handling. An incorrect approach that focuses solely on providing basic training without assessing specific tasks or implementing mechanical aids fails to adequately address the root causes of potential injuries. This approach is ethically and regulatorily deficient because it places undue reliance on the individual worker's ability to adapt, rather than the employer's responsibility to engineer out hazards or provide appropriate tools. Such an approach may violate the spirit, if not the letter, of regulations that require employers to implement effective hazard control measures. Another incorrect approach that prioritizes the immediate implementation of mechanical aids without proper risk assessment or worker training is also problematic. While mechanical aids are crucial, their effectiveness depends on proper selection, installation, and user proficiency. Without understanding the specific tasks and the capabilities of the workforce, simply introducing equipment can lead to misuse, new hazards, or resistance from employees, failing to achieve the desired safety outcomes and potentially creating new compliance issues. A third incorrect approach that relies solely on individual worker self-assessment and reporting of discomfort, without a proactive employer-driven program, is insufficient. While employee feedback is valuable, It is reactive and may not capture all risks, especially those that develop over time or are not immediately perceived as painful. This approach abdicates the employer's responsibility to systematically identify and control hazards, which is a core tenet of occupational safety and health management. The professional decision-making process for similar situations should involve a systematic risk assessment, starting with identifying all manual material handling tasks. This should be followed by evaluating the risks associated with each task, considering factors like weight, frequency, posture, and environmental conditions. Based on this assessment, the REHS/RES should then apply the hierarchy of controls: elimination, substitution, engineering controls, mechanical aids, administrative controls, training, work practices, job rotation, and finally, personal protective equipment. Continuous monitoring, evaluation, and feedback loops with employees are essential to ensure the effectiveness of implemented controls and to adapt to changing conditions. Question 9. Investigation of workplace activities involving powered equipment has identified potential exposure to both hand-arm vibration, HAV, and whole-body vibration, WBV. Which of the following approaches most accurately reflects the regulatory framework and best practices for managing these distinct exposures under U.S. OSHA guidelines? Option A. Prioritize the implementation of advanced personal protective equipment, PPE, such as specialized gloves and anti-vibration mats for all workers operating any powered machinery, as this offers the most direct protection against vibration. Option B. Focus on a general vibration reduction strategy by ensuring all powered equipment is well maintained and that workers take regular breaks, assuming this will adequately address both HAV and WBV risks. Option C. Conduct a single, overarching vibration survey using standardized measurement equipment and apply a uniform set of health surveillance protocols for all employees potentially exposed to any form of vibration. Option D. Implement a comprehensive program that includes identifying tools and equipment causing HAV and assessing their use, while separately identifying tasks involving WBV exposure through seating or flooring and evaluating those exposures, followed by tailored control measures for each type of vibration. Correct answer is D. Implement a comprehensive program that includes identifying tools and equipment causing HAV and assessing their use, while separately identifying tasks involving WBV exposure through seating or flooring and evaluating those exposures, followed by tailored control measures for each type of vibration. Explanation. The scenario presents a common challenge for an environmental, safety, and health ESH manager, differentiating between the risks and control strategies for hand-arm vibration, HAV, and whole-body vibration, WBV, in a workplace. This requires a nuanced understanding of how these distinct vibration types affect workers and the specific regulatory requirements for each. The professional challenge lies in accurately identifying the primary vibration exposure and applying the correct set of control measures and regulatory compliance strategies, rather than conflating the two. The correct approach involves a systematic assessment that first identifies the source and type of vibration exposure. For HAV, this means focusing on tools and equipment that transmit vibration directly to the hands and arms, such as pneumatic drills or grinders. For WBV, the focus shifts to the vibration transmitted through the seat or floor of vehicles or machinery, affecting the entire body. The correct approach will then align control measures with the identified vibration type, referencing the specific requirements of the relevant U.S. Occupational Safety and Health Administration, OSHA, standards and guidance documents that address vibration exposure. This includes understanding the concept of exposure limits, the need for risk assessment, and the hierarchy of controls as applied to each vibration type. For instance, for HAV, the focus would be on tool selection, maintenance, and work practices, while for WBV, it might involve vehicle suspension, seat design, and job rotation. An incorrect approach would be to apply generic vibration control measures, without differentiating between HAV and WBV. This fails to address the specific mechanisms of exposure and the distinct health effects associated with each. For example, suggesting improved seating for a worker operating a handheld vibrating tool would be misdirected and ineffective for controlling HAV. Similarly, focusing solely on tool maintenance for a driver experiencing significant WBV would overlook the primary sources of exposure. Ethically and regulatorily, this demonstrates a failure to conduct a thorough risk assessment and to implement controls that are proportionate and effective for the identified hazards, potentially leading to continued worker exposure and noncompliance with OSHA General Duty Clause and any specific guidance on vibration. Another incorrect approach would be to assume that a single set of measurement techniques or health surveillance protocols applies equally to both HAV and WBV, ignoring the specialized equipment and methodologies required for each. Professional decision-making in such situations requires a structured approach. 1. Hazard identification. Clearly distinguish between tools/activities causing HAV and those causing WBV. 2. Risk assessment. Evaluate the magnitude, frequency, and duration of exposure for each type of vibration. 3. Regulatory review. Consult relevant OSHA standards and guidance for both HAV and WBV. 4. Control measure selection. Apply the hierarchy of controls, elimination, substitution, engineering, administrative PPE, specifically tailored to the identified vibration type. 5. Monitoring and review. Implement appropriate measurement and health surveillance strategies for each type of vibration. Question 10. The performance metrics show a significant increase in reported incidents related to improper material handling over the past quarter. As the REHS/RS, which of the following approaches best addresses this trend to ensure long-term safety improvement and regulatory compliance? Option A. Focus on issuing disciplinary actions to employees involved in recent incidents and mandate a mandatory 1-hour general safety refresher course for all personnel. Option B. Conduct a thorough review of the existing written material handling procedures, develop targeted training modules based on identified gaps, and implement a communication plan to disseminate updated information and training schedules. Option C. Issue a general safety reminder to all employees about the importance of safe material handling and increase the frequency of general safety inspections. Option D. Invest in new, automated material handling equipment to reduce the reliance on manual labor, assuming this will inherently improve safety. Correct answer is B. Conduct a thorough review of the existing written material handling procedures, develop targeted training modules based on identified gaps, and implement a communication plan to disseminate updated information and training schedules. Explanation. The performance metrics show a concerning trend in workplace incidents related to improper material handling. This scenario is professionally challenging because it requires the registered environmental safety and health manager, REHS/RS, to not only identify the root cause of the incidents, but also to implement effective programmatic solutions that address systemic issues. The REHS/RS must balance the immediate need for corrective action with the long-term goal of fostering a robust safety culture. This requires a deep understanding of regulatory requirements for written safety programs, training, and communication, as well as the ability to critically evaluate different approaches to program enhancement. The correct approach involves a comprehensive review of the existing written safety program, specifically focusing on the material handling procedures. This review should identify gaps in clarity, completeness, and accessibility of information. Subsequently, targeted training modules should be developed and delivered to all affected employees, ensuring the training is practical, hands-on where appropriate, and addresses the specific hazards identified. Effective communication channels must be established or reinforced to ensure that updated procedures and training are disseminated and understood. Finally, a robust record-keeping system is essential to document training completion, incident investigations, and the effectiveness of implemented controls. This approach aligns with the fundamental principles of OSHA General Duty Clause 29 CFR 1910-132, which mandates employers provide a workplace free from recognized hazards, and specific standards related to hazard communication 29 CFR 1910-1200, and training 29 CFR 1910-132D, emphasizing the need for documented, effective safety programs and employee training. Ethically, this approach prioritizes employee well-being by proactively addressing hazards and ensuring they have the knowledge and skills to work safely. An incorrect approach would be to solely rely on a one-time, generic safety briefing for all employees without specific content tailored to material handling risks. This fails to address the identified deficiencies in the written program and provides insufficient, non-specific training. It also bypasses the critical step of reviewing and updating procedures, which is the likely source of the problem. This approach violates regulatory requirements for specific hazard training and demonstrates a lack of due diligence in hazard identification and control. Another incorrect approach would be to focus exclusively on disciplinary actions for employees involved in incidents without investigating the underlying programmatic failures. While accountability is important, this reactive measure does not prevent future incidents and ignores the employer's responsibility to provide adequate training and safe work procedures. This approach fails to meet the spirit and letter of OSHA regulations that require proactive hazard abatement and program development. A third incorrect approach would be to implement new, complex equipment for material handling without adequately updating written procedures or providing comprehensive training on its use. This could introduce new hazards and increase the likelihood of incidents, as employees may not understand the safe operating parameters or emergency procedures. This demonstrates a failure in the hazard assessment and control process, as well as in the communication and training elements of a safety program. Professionals should employ a systematic, data-driven approach to safety program management. This involves 1. Analyzing performance metrics to identify trends and potential hazards. 2. Conducting thorough root cause analyses of incidents. 3. Reviewing and updating written safety programs, policies, and procedures to ensure they are clear, comprehensive, and address identified hazards. 4. Developing and delivering targeted, effective training programs. 5. Establishing clear communication channels for safety information. And 6. Maintaining accurate and complete records. This iterative process ensures continuous improvement and compliance with regulatory requirements, ultimately fostering a safer working environment. Question 11. Cost-benefit analysis shows that implementing a new advanced filtration system to significantly reduce particulate emissions from a manufacturing process would incur substantial upfront costs. However, a preliminary qualitative risk assessment indicates a moderate potential for localized air quality degradation and associated health impacts on a nearby community. Given these findings, which approach best aligns with the REHS' professional responsibilities and regulatory expectations under U.S. federal environmental and occupational safety laws? Option A. Defer the decision pending further, less resource-intensive qualitative assessments to confirm the severity of the risk, as the current assessment is only moderate. Option B. Implement a less expensive, less technologically advanced control measure that offers some reduction in emissions, as the qualitative assessment does not definitively prove a high risk requiring the most expensive solution. Option C. Recommend against the advanced filtration system, arguing that the upfront costs outweigh the current moderate qualitative risk assessment, and focus on less expensive, less effective control measures. Option D. Proceed with the advanced filtration system, justifying the expenditure through a detailed quantitative risk assessment that quantifies the reduction in health risks and environmental damage, and compares this to the system's cost. The correct answer is D. Proceed with the advanced filtration system, justifying the expenditure through a detailed quantitative risk assessment that quantifies the reduction in health risks and environmental damage, and compares this to the system's cost. Explanation: this scenario is professionally challenging because it requires the registered environmental safety and health manager, REHS/RS, to balance the financial implications of a proposed control measure against its effectiveness in mitigating a significant environmental risk. The REHS/RS must demonstrate a thorough understanding of both qualitative and quantitative risk assessment methodologies and their application within the relevant regulatory framework, which for this exam is assumed to be U.S. federal regulations, specifically those enforced by the Environmental Protection Agency, EPA, and Occupational Safety and Health Administration, OSHA. The core of the challenge lies in selecting the most appropriate risk assessment approach that aligns with regulatory requirements, ethical obligations, and the principle of protecting public health and the environment, even when faced with cost pressures. The correct approach involves utilizing a quantitative risk assessment to determine the likelihood and severity of the environmental impact, then comparing this to the cost of implementing the proposed control measure. This aligns with regulatory expectations that environmental and safety decisions be based on objective data and a systematic evaluation of risk. For instance, EPA regulations often mandate or encourage quantitative risk assessment for certain hazardous substances or processes to ensure that residual risks are acceptable. OSHA standards, particularly those related to process safety management, PSM, also emphasize a data-driven approach to risk assessment to prevent catastrophic releases. A quantitative assessment provides a more precise understanding of risk levels, allowing for a more informed cost-benefit analysis that prioritizes the most effective risk reduction strategies. This approach upholds the ethical responsibility of the REHS to ensure a safe and healthy environment based on sound scientific principles and regulatory compliance. An incorrect approach would be to solely rely on a qualitative risk assessment without considering the potential for a more precise quantitative evaluation, especially when significant environmental impacts are possible. While qualitative methods are useful for initial screening, they can be subjective and may not provide sufficient detail to justify or refute a costly control measure. This could lead to underestimating or overestimating the risk, potentially resulting in either inadequate protection or unnecessary expenditure, both of which are professionally unacceptable and could violate regulatory principles that demand a robust understanding of risk. Another incorrect approach would be to prioritize cost savings over a comprehensive risk assessment, even if the qualitative assessment suggests a moderate risk. This disregards the precautionary principle often embedded in environmental and safety regulations, which dictates that action should be taken to prevent harm, even if scientific certainty is not absolute. Ethically, the REHS has a duty to protect the environment and public health, which supersedes purely financial considerations when a credible risk exists. A third incorrect approach would be to select a control measure based on its perceived simplicity or familiarity rather than its demonstrated effectiveness in reducing the specific identified risk, as determined by a rigorous assessment. This bypasses the core purpose of risk assessment, which is to identify the most effective and efficient means of controlling hazards. Regulatory frameworks emphasize the selection of controls based on their ability to reduce risk to acceptable levels, not on convenience or tradition. Professional decision-making in similar situations requires a structured approach. 1. Clearly define the hazard and potential environmental impact. 2. Conduct an appropriate risk assessment, starting with qualitative methods if necessary, but progressing to quantitative methods when the potential for significant impact or the need for precise justification of controls warrants it. 3. Evaluate the effectiveness of proposed control measures against the identified risks. 4. Perform a cost-benefit analysis that integrates the findings of the risk assessment with the costs of controls, ensuring that regulatory requirements and ethical obligations are met. 5. Document the entire process thoroughly, including the rationale for the chosen approach and the final decision. Question 12. The review process indicates that a manufacturing facility has identified potential noise hazards in its assembly area, with employees reporting difficulty communicating and experiencing ringing in their ears after shifts. As the REHS, which of the following approaches best addresses this physical hazard in accordance with U.S. occupational safety and health regulations? Option A. Immediately provide all employees in the assembly area with high-attenuation hearing protection devices and instruct them on their proper use. Option B. Conduct a comprehensive noise survey to measure sound levels and employee exposure, then implement a hierarchy of controls starting with engineering solutions, followed by administrative controls, and finally, providing appropriate hearing protection as a last resort. Option C. Perform occasional, informal sound level checks during different operational periods to get a general sense of the noise environment. Option D. Implement a brief annual training session for employees on the general risks associated with loud noises and the importance of reporting any discomfort. The correct answer is B. Conduct a comprehensive noise survey to measure sound levels and employee exposure, then implement a hierarchy of controls starting with engineering solutions, followed by administrative controls, and finally, providing appropriate hearing protection as a last resort. Explanation. This scenario presents a professional challenge because it requires the registered environmental safety and health manager, REHS, to interpret and apply specific regulatory requirements for physical hazards in a practical setting, balancing compliance with operational efficiency. The core of the challenge lies in accurately identifying and mitigating risks associated with noise exposure, a common physical hazard in many workplaces, and ensuring that the chosen control measures are both effective and legally sound according to the specified regulatory framework. The correct approach involves a systematic evaluation of noise levels against established permissible exposure limits, PEL, and implementing a hierarchy of controls, prioritizing elimination or substitution, followed by engineering controls, administrative controls, and finally, personal protective equipment, PPE. This approach is correct because it directly aligns with the principles of occupational safety and health management, mandated by relevant U.S. regulations, such as those promulgated by the Occupational Safety and Health Administration (OSHA). Specifically, OSHA General Duty Clause requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. Furthermore, specific standards, like 29 CFR 1910-95 for occupational noise exposure, provide detailed requirements for noise measurement, exposure assessment, and the implementation of control measures, including hearing conservation programs when noise levels exceed action levels. Ethical considerations also dictate a proactive approach to employee well-being, ensuring that potential hearing loss is prevented through robust and compliant hazard mitigation strategies. An incorrect approach that relies solely on providing hearing protection without assessing noise levels or exploring engineering controls fails to meet regulatory requirements. This is because it bypasses the mandated hierarchy of controls, which prioritizes more effective and sustainable solutions over reliance on PPE, which can be prone to improper use, failure, or discomfort. Ethically, it places the burden of protection on the employee rather than the employer's primary responsibility to eliminate or reduce the hazard at its source. Another incorrect approach that involves only occasional spot checks of noise levels without a comprehensive monitoring program or a defined action plan for exceeding limits is also professionally unacceptable. This approach is deficient because it lacks the systematic and documented approach required by regulations for ongoing hazard assessment and control. It fails to establish a baseline, track trends, or ensure that intermittent high noise exposures are adequately addressed, potentially leading to cumulative hearing damage and noncompliance. A third incorrect approach that focuses on employee training on the risks of noise without implementing any physical controls or monitoring is also flawed. While training is a component of a safety program, it is insufficient on its own to mitigate a physical hazard like excessive noise. Regulations require tangible measures to reduce exposure, not just awareness. Relying solely on training abdicates the employer's responsibility to engineer out or control the hazard at its source. The professional reasoning process for similar situations should involve a thorough understanding of applicable U.S. federal and state OSHA regulations, as well as any relevant consensus standards, e.g., NIOSH. This includes conducting a comprehensive hazard assessment, documenting all findings and control measures, and establishing a system for ongoing monitoring and review. The decision-making process should always prioritize the hierarchy of controls, seeking the most effective and sustainable solutions to protect worker health and safety while ensuring full regulatory compliance. Question 13. The efficiency study reveals that several chemicals with varying flammability, corrosivity, and reactivity profiles are being stored in close proximity within a shared warehouse space. The current storage arrangement appears to be based on general hazard categories rather than specific chemical compatibility data. What is the most appropriate regulatory compliant approach for the REHS/REHS to address this situation? Option A. Relocate all chemicals to a single, large, well-ventilated area to ensure adequate air circulation and minimize the risk of vapor buildup. Option B. Consult with the warehouse staff to understand their current practices and implement minor adjustments based on their feedback to improve efficiency. Option C. Implement a general flammable liquid storage protocol for all chemicals in the area, assuming a worst-case scenario for all substances. Option D. Conduct a detailed review of the safety data sheets, SDS, for each chemical, consult chemical compatibility charts, and implement storage segregation and containment strategies in accordance with OSHA 29 CFR 1910 Subpart H and 29 CFR 1910. 1200. The correct answer is D. Conduct a detailed review of the safety data sheets, SDS, for each chemical, consult chemical compatibility charts, and implement storage segregation and containment strategies in accordance with OSHA 29 CFR 1910 Subpart H and 29 CFR 1910. 1200. Explanation. The efficiency study reveals a potential hazard in the storage of reactive chemicals. This scenario is professionally challenging because it requires the registered Environmental Safety and Health Manager, REHS/RS, to not only identify a risk, but also to implement a solution that is compliant with stringent regulatory requirements, specifically focusing on chemical properties and reactivity. The REHS/RS must possess a deep understanding of flammability, corrosivity, explosivity, and chemical compatibility to prevent incidents like fires, explosions, or the release of toxic substances. The professional judgment required lies in accurately assessing the risks associated with the identified chemicals and selecting the most appropriate and legally defensible control measures. The correct approach involves a thorough review of the safety data sheets, SDS, for all chemicals involved, cross-referencing this information with established chemical compatibility charts and relevant sections of the Occupational Safety and Health Administration, OSHA, standards, particularly 29 CFR 1910 Subpart H, hazardous materials, and 29 CFR 1910, 1200, hazard communication standard. This approach ensures that storage practices are based on documented scientific data and regulatory mandates, addressing flammability, corrosivity, explosivity, and compatibility to prevent dangerous reactions. The regulatory justification is rooted in OSHA General Duty Clause, Section 5(a)(1) of the OSH Act, which requires employers to provide a workplace free from recognized hazards, and the specific requirements for safe storage and handling of hazardous chemicals outlined in the cited standards. Ethically, the REHS/RS has a duty to protect workers and the environment. An incorrect approach would be to rely solely on anecdotal evidence or past practices without consulting SDS and regulatory guidelines. This fails to address the specific chemical properties and reactivity, potentially leading to incompatible storage that could result in fires or the release of hazardous vapors, violating OSHA Hazard Communication Standard and the General Duty Clause. Another incorrect approach would be to implement generic safety measures without considering the unique reactivity profiles of the stored chemicals. For instance, storing all chemicals in a single, well-ventilated area without regard for their specific compatibility could still lead to dangerous reactions if, for example, an oxidizer is placed next to a flammable material. This overlooks the critical aspect of chemical compatibility and violates the principle of risk-based safety management mandated by OSHA. A third incorrect approach would be to prioritize cost savings over safety by using inadequate or non-compliant storage containers or segregation methods. This directly contravenes the regulatory requirements for proper containment and segregation of hazardous materials, increasing the risk of leaks, spills, and dangerous reactions, and failing to uphold the ethical obligation to provide a safe working environment. The professional decision-making process for similar situations should begin with a comprehensive hazard identification and risk assessment. This involves gathering all relevant information about the chemicals, including their SDS. Next, the REHS/RS must consult applicable federal, state, and local regulations, as well as industry best practices. Based on this information, appropriate control measures, such as segregation, ventilation, and appropriate container selection, should be developed and implemented. Regular review and auditing of these measures are crucial to ensure ongoing compliance and effectiveness. Question 14. Assessment of a potential occupational health hazard requires a thorough understanding of a chemical's toxicological profile. Given a scenario where workers are exposed to a novel industrial solvent, which approach best ensures the identification and mitigation of potential health risks? Option A. Assume that any detectable level of the solvent in the air poses a significant health risk and implement stringent controls immediately. Option B. Prioritize understanding the solvent's flammability and vapor pressure to manage immediate fire and explosion risks. Option C. Research the solvent's acute and chronic toxicity data, identify primary routes of entry, and determine likely target organs based on established dose-response relationships. Option D. Rely solely on the information provided in the manufacturer's safety data sheet, SDS, without further toxicological investigation. The correct answer is B. Prioritize understanding the solvent's flammability and vapor pressure to manage immediate fire and explosion risks. Explanation. Scenario analysis. This scenario presents a common challenge for an REHS/RS, evaluating the potential health risks associated with a chemical exposure in the workplace. The challenge lies in accurately interpreting toxicological data, understanding dose-response relationships, and identifying the most likely routes of entry and target organs for a specific substance. This requires not only a strong understanding of toxicology principles, but also the ability to apply them within the context of regulatory compliance and worker protection. The REHS/RS must move beyond simply identifying a chemical to understanding its inherent hazards and how those hazards might manifest in a real-world exposure scenario. Correct approach analysis. The correct approach involves a systematic evaluation that begins with identifying the specific chemical and its known toxicological profile. This includes researching its acute and chronic toxicity data, understanding the dose-response relationship, i.e., how the severity of effect changes with the dose, and determining the primary routes of entry into the body, inhalation, dermal absorption, ingestion, injection. Based on this information, the REHS/RS can then identify the most likely target organs and the potential health effects. This comprehensive understanding allows for the development of appropriate control measures, such as engineering controls, administrative controls, and personal protective equipment, PPE, to minimize worker exposure and prevent adverse health outcomes. This aligns with the fundamental responsibilities of an REHS/RS to protect worker health and safety by proactively identifying and mitigating hazards, as mandated by regulations such as OSHA Hazard Communication Standard, 29 CFR 1910, 1200, and General Duty Clauses. Incorrect approaches analysis. Focusing solely on the chemical's physical properties without considering its toxicological effects is a significant failure. Physical properties, e.g., flammability, volatility, are important for safety but do not directly address the health hazards posed by exposure. This approach neglects the core mandate of assessing health risks. Assuming that any exposure above a certain threshold is automatically harmful without considering the specific dose-response relationship for that chemical is also problematic. Toxicology is dose-dependent. A substance may have a low toxicity at low doses but become hazardous at higher doses. This approach lacks the nuance required for accurate risk assessment and could lead to either unnecessary alarm or inadequate protection. Relying exclusively on the safety data sheet, SDS, without further investigation or contextualization is insufficient. While SDSs are a critical source of information, they provide a general overview. And REHS/RS must be able to interpret the SDS in the context of the specific workplace operation, potential exposure scenarios, and the limitations of the data provided. Over-reliance without critical analysis can lead to misinterpretations or overlooking crucial details relevant to the specific exposure. Professional reasoning. When faced with a potential chemical exposure, the REHS/RS should employ a structured risk assessment process. This begins with hazard identification, which involves thoroughly researching the chemical's toxicological properties. Next, exposure assessment is conducted to understand how workers might come into contact with the substance, considering routes of entry and potential exposure levels. This is followed by risk characterization, where the hazard and exposure information are combined to estimate the likelihood and severity of adverse health effects. Finally, risk management strategies are developed and implemented, including control measures and monitoring. This systematic approach ensures that decisions are based on sound scientific principles and regulatory requirements, prioritizing worker health and safety. Question 15. Upon reviewing the safety records and recent near-miss reports at a manufacturing facility, the Registered Environmental Safety and Health Manager, REHS/RS, identifies a need to enhance training in hazard communication, emergency response, personal protective equipment, PPE, fall protection, lockout/tagout, and confined space entry. Which of the following approaches best ensures regulatory compliance and worker safety under U.S. OSHA regulations? Option A. Develop and deliver comprehensive training modules that are tailored to the specific hazards, chemicals, equipment, and procedures present at the facility, incorporating accessible delivery methods and verification of employee comprehension, while ensuring all training aligns with relevant OSHA standards such as 29 CFR 1910, 1200, 29 CFR 1910, 120, and Subpart I. Option B. Assign the responsibility for developing and delivering all required safety training to individual department supervisors, providing them with a basic outline of the topics to cover. Option C. Focus on creating detailed training documentation and sign-in sheets for each topic, assuming that the existence of these records demonstrates adequate training compliance. Option D. Procure generic, widely available training materials on the listed topics and distribute them to all employees, with supervisors responsible for ensuring employees review the materials. Correct answer is A. Develop and deliver comprehensive training modules that are tailored to the specific hazards, chemicals, equipment, and procedures present at the facility, incorporating accessible delivery methods and verification of employee comprehension, while ensuring all training aligns with relevant OSHA standards such as 29 CFR 1910, 1200, 29 CFR 1910, 120, and Subpart I. Explanation. Scenario analysis. This scenario presents a common challenge for REHS/REHS, ensuring effective hazard communication and emergency preparedness in a dynamic industrial setting. The challenge lies in translating regulatory requirements into practical, actionable training that addresses the specific hazards present and the diverse needs of the workforce. A failure in this area can lead to serious incidents, injuries, or fatality, underscoring the critical need for a thorough and compliant approach. Correct approach analysis. The correct approach involves a comprehensive review of the facility's specific hazards, existing safety programs, and relevant OSHA standards, specifically 29 CFR 1910 Subpart Z for hazardous chemicals, 29 CFR 1910, 120 for HAZWOPER if applicable, and 29 CFR 1910, 1200 for hazard communication. This review informs the development of tailored training modules that cover not only the general requirements of hazard communication, emergency response, PPE, fall protection, lockout/tagout, and confined space entry, but also the specific chemicals, equipment, and procedures unique to the facility. The training must be delivered in a manner accessible to all employees, considering language barriers and varying levels of literacy, and include methods for verifying comprehension and effectiveness. This aligns with OSHA emphasis on employer responsibility for ensuring a safe and healthy workplace through effective training and communication. Incorrect approach is analysis. An approach that focuses solely on providing generic, off-the-shelf training materials without assessing site-specific hazards or employee needs fails to meet regulatory requirements. OSHA Hazard Communication Standard, for instance, mandates that employers inform employees about the hazards of chemicals in their work area, which necessitates training tailored to the actual chemicals present. Similarly, emergency response training must address the specific types of emergencies the facility might face. This generic approach also risks overlooking critical site-specific risks in areas like fall protection or confined space entry, leading to potential noncompliance and increased risk of incidents. An approach that prioritizes compliance documentation over actual training effectiveness is also flawed. While record-keeping is essential, simply having training records without ensuring that employees understand the material and can apply it in practice is a significant regulatory and ethical failure. The intent of these regulations is to protect workers, not merely to satisfy auditors. If employees cannot demonstrate understanding or apply safety procedures, the training has been ineffective, regardless of the paperwork. An approach that delegates all training responsibilities to individual department supervisors without providing them with adequate resources, standardized training content, or oversight is problematic. While supervisors play a crucial role, they may lack the expertise or time to develop and deliver comprehensive, compliant training across all required topics. This can lead to inconsistencies in training quality and content, potentially leaving gaps in employee knowledge and increasing risk. The REHS/REHS has a responsibility to ensure a consistent and effective safety training program across the entire organization. Professional reasoning. Professionals should adopt a systematic, risk-based approach. This begins with a thorough hazard assessment and a review of applicable regulations, primarily OSHA standards for U.S.-based REHS/REHS roles. The next step is to develop a training program that directly addresses identified hazards and regulatory mandates, incorporating site-specific elements. Training delivery should be engaging, accessible, and include mechanisms for assessing comprehension and effectiveness. Continuous evaluation and updating of the training program based on incident data, regulatory changes, and feedback are crucial for maintaining a robust safety culture. Question 16. Risk assessment procedures indicate a recent significant incident involving a chemical spill. The investigation revealed contributing factors related to improper handling procedures and a lack of understanding of emergency response protocols among affected personnel. As the Registered Environmental, Safety and Health Manager, REHS/RS, what is the most appropriate approach to address the training needs arising from this incident? Option A. Update existing chemical handling and emergency response training modules with minor revisions to reflect the incident's general nature. Option B. Develop new training materials based on the perceived obvious causes of the incident, focusing on immediate corrective actions. Option C. Conduct a comprehensive training needs assessment directly linked to the incident investigation findings, develop targeted training objectives and programs, and implement a robust evaluation strategy to measure effectiveness. Option D. Implement a generic, site-wide refresher training on general chemical safety to ensure all employees receive basic awareness. The correct answer is C. Conduct a comprehensive training needs assessment directly linked to the incident investigation findings, develop targeted training objectives and programs, and implement a robust evaluation strategy to measure effectiveness. Explanation. Scenario analysis. This scenario presents a common challenge for an environmental, safety, and health manager. A significant incident has occurred, and the immediate need is to prevent recurrence. The professional challenge lies in moving beyond a reactive response to a proactive and systematic approach to training. Simply providing generic safety training without understanding the root causes and specific knowledge gaps identified by the incident investigation would be insufficient and potentially ineffective. The ESH manager must demonstrate a thorough understanding of the regulatory requirements for training, the principles of adult learning, and the importance of a data-driven approach to training needs assessment and evaluation. Failure to do so could lead to continued risks, regulatory noncompliance, and potential harm to personnel or the environment. Correct approach analysis. The correct approach involves a comprehensive training needs assessment directly linked to the incident investigation findings. This begins with a detailed analysis of the incident to identify specific knowledge, skill, and attitude gaps that contributed to its occurrence. Based on these identified gaps, targeted training objectives are developed. The training program is then designed to directly address these objectives, utilizing appropriate adult learning principles to ensure engagement and retention. Finally, a robust evaluation mechanism is implemented to measure the effectiveness of the training in closing the identified gaps and preventing future incidents. This systematic, data-driven approach aligns with regulatory expectations for effective ESH management programs, which often mandate that training be relevant, effective, and documented. Ethically, it demonstrates a commitment to worker safety and continuous improvement. Incorrect approach is analysis. Implementing a generic, one-size-fits-all safety training program without a specific needs assessment fails to address the unique contributing factors of the recent incident. This approach is procedurally flawed because it bypasses the critical step of identifying specific knowledge or skill deficiencies, making the training potentially irrelevant to the actual risks. It also risks regulatory noncompliance if regulations require training to be tailored to specific hazards or job functions. Developing training based solely on the perceived obvious causes of the incident, without a formal investigation and needs assessment, is also problematic. This relies on assumptions rather than data, which can lead to overlooking less apparent but equally critical training needs. It lacks the rigor required for effective ESH management and may not satisfy regulatory requirements for documented risk mitigation strategies. Focusing exclusively on updating existing training materials without a fresh assessment of needs is insufficient. While updating is important, it does not guarantee that the updated content addresses the specific gaps revealed by the incident. The incident may highlight entirely new or previously underestimated risks that require novel training approaches, not just minor revisions to existing content. Professional reasoning. Professionals in ESH management should adopt a structured, problem-solving approach. When an incident occurs, the first step is a thorough investigation to understand root causes and contributing factors. This investigation directly informs the training needs assessment. The assessment should identify specific knowledge, skill, and attitude deficiencies. Based on these identified needs, training objectives should be clearly defined. The training program design should then directly align with these objectives, incorporating effective adult learning methodologies. Crucially, a plan for evaluating the training's effectiveness must be established before implementation, allowing for adjustments and verification that the intended outcomes have been achieved. This cyclical process of assessment, design, delivery, and evaluation ensures that training is a dynamic and effective tool for risk reduction and regulatory compliance. Question 17. Performance analysis shows that a renovation project involves the removal of old flooring containing asbestos, scraping of painted surfaces potentially containing lead, and the use of various solvents for cleaning and adhesive removal. Which approach best addresses the specific chemical hazards and ensures compliance with relevant U.S. federal OSHA regulations? Option A. Focus primarily on controlling the immediate vapor hazards from solvents, as they present the most acute risk, and address asbestos and lead only if visible dust or debris is generated. Option B. Rely on general industry safety guidelines and best practices for chemical handling, without specific reference to OSHA standards for asbestos, lead, or solvents. Option C. Conduct a detailed risk assessment for each chemical hazard, prioritizing control measures according to the hierarchy of controls: elimination, substitution, engineering, administrative, PPE, and implement specific abatement and control procedures for asbestos, lead, and solvents as mandated by OSHA standards. Option D. Provide workers with appropriate personal protective equipment, PPE, for each chemical hazard and conduct general safety training on chemical handling. The correct answer is C. Conduct a detailed risk assessment for each chemical hazard, prioritizing control measures according to the hierarchy of controls: elimination, substitution, engineering, administrative, PPE, and implement specific abatement and control procedures for asbestos, lead, and solvents as mandated by OSHA standards. Explanation: this scenario is professionally challenging because it requires the Registered Environmental Safety and Health Manager, REHS/RS, to move beyond simple hazard identification to a nuanced risk assessment for multiple, potentially synergistic chemical hazards. The presence of asbestos, lead, and solvents in a renovation project necessitates a comprehensive understanding of their specific exposure routes, health effects, and regulatory control measures under U.S. federal and state OSHA standards. The REHS/RS must not only identify these hazards, but also evaluate the likelihood and severity of exposure during the renovation activities, considering factors like material condition, work practices, and the effectiveness of existing controls. This requires a deep understanding of the specific requirements for asbestos abatement, lead paint removal, and solvent handling, as well as the general duty clause to protect workers from recognized hazards. The correct approach involves a systematic risk assessment that prioritizes control measures based on the hierarchy of controls, as mandated by OSHA Hazard Communication Standard 29 CFR 1910, 1200, and specific standards for asbestos 29 CFR 1926, 1101, and lead 29 CFR 1926. 62. This approach begins with a thorough site survey to identify the location and condition of asbestos-containing materials, ACM, and lead-based paint, LBP. It then assesses potential exposure pathways during renovation activities, such as dust generation from cutting or sanding, vapor inhalation from solvents, and ingestion of lead dust. Based on this assessment, appropriate control measures are selected, starting with elimination or substitution if feasible, followed by engineering controls, e.g., containment, ventilation, administrative controls, e.g., work practices, training, and finally, personal protective equipment, PPE. This aligns with the ethical obligation to protect worker health and safety and the regulatory requirement to implement effective hazard control programs. An approach that focuses solely on personal protective equipment, PPE, without a thorough risk assessment and consideration of higher-level controls is professionally unacceptable. This fails to meet the regulatory requirements of OSHA standards, which mandate a hierarchy of controls, prioritizing elimination, substitution, engineering, and administrative controls before relying on PPE. Ethically, it places an undue burden on the worker and may not provide adequate protection against significant exposures, particularly for chronic hazards like asbestos and lead. Another incorrect approach would be to only address the most immediately obvious hazard, such as the solvents, while neglecting the latent but significant risks posed by asbestos and lead. This demonstrates a failure to conduct a comprehensive hazard identification and risk assessment, violating the REHS/REHS's duty to identify all recognized hazards present at the worksite. OSHA General Duty Clause requires employers to provide a workplace free from recognized hazards likely to cause death or serious physical harm, which would encompass all three identified chemical hazards. Finally, an approach that relies on generic safety guidelines without referencing or applying the specific regulatory requirements for asbestos, lead, and solvents under OSHA is insufficient. While general safety principles are important, the REHS/REHS must demonstrate competence in applying the detailed provisions of relevant standards, including permissible exposure limits, PEL, monitoring requirements, training mandates, and abatement procedures. Failure to do so constitutes a regulatory and ethical lapse, as it may lead to non-compliance and inadequate protection. The professional decision-making process for similar situations should involve a structured risk assessment framework. This includes 1. Hazard identification. Systematically identify all potential chemical hazards present. 2. Exposure assessment. Evaluate the likelihood and magnitude of exposure for each hazard, considering the specific tasks and work environment. 3. Risk characterization. Determine the level of risk associated with each hazard based on exposure and toxicity. 4. Control strategy development. Select and implement control measures following the hierarchy of controls. 5. Monitoring and review. Continuously monitor the effectiveness of controls and review the risk assessment as conditions change. This systematic process ensures that all relevant hazards are addressed comprehensively and in accordance with regulatory requirements and ethical obligations. Question 18. Implementation of a comprehensive noise control strategy in a manufacturing facility requires careful consideration of various control measures. Given the regulatory framework for occupational noise exposure, which approach best prioritizes worker health and safety while adhering to the hierarchy of controls. Option A. Implementing administrative controls, such as job rotation and limiting time spent in noisy areas, as the primary means of reducing exposure. Option B. Selecting the least expensive noise reduction option available that meets the minimum regulatory sound level requirements, regardless of its effectiveness in reducing overall exposure. Option C. Focusing primarily on a robust hearing protection program, ensuring all employees are properly fitted and trained on the use of earplugs and earmuffs. Option D. Prioritizing the implementation of engineering controls to reduce noise at its source, supplemented by administrative controls and hearing protection programs as necessary. The correct answer is D. Prioritizing the implementation of engineering controls to reduce noise at its source, supplemented by administrative controls and hearing protection programs as necessary. Explanation. This scenario is professionally challenging because it requires a REHS/REHS to balance the immediate need for operational efficiency with the long-term health and safety of employees, specifically concerning noise exposure. The challenge lies in selecting the most effective and compliant noise control strategy when multiple options exist, each with varying degrees of effectiveness, cost, and impact on work processes. Careful judgment is required to ensure that the chosen strategy not only meets regulatory requirements, but also provides adequate protection and is sustainable. The correct approach involves prioritizing engineering controls as the primary method for noise reduction. This is because engineering controls, such as enclosing noisy machinery or installing silencers, address the noise at its source, offering the most effective and permanent solution. This aligns with the hierarchy of controls mandated by occupational safety regulations, which emphasizes eliminating or substituting hazards, followed by engineering controls, administrative controls, and finally, personal protective equipment, PPE. Ethically, this approach demonstrates a commitment to proactive risk management and the well-being of workers by minimizing exposure at the source. An incorrect approach would be to solely rely on hearing protection programs without first exploring engineering controls. While hearing protection is a crucial component of a comprehensive noise control strategy, it is considered the least effective control measure as it relies on consistent and correct use by the individual worker. Regulations typically mandate that hearing protection be used when engineering and administrative controls cannot sufficiently reduce noise levels to within permissible exposure limits. Failing to implement engineering controls first represents a regulatory failure to adhere to the hierarchy of controls and an ethical failure to provide the highest level of protection. Another incorrect approach would be to implement administrative controls, such as rotating employees through noisy areas, as the primary solution. While administrative controls can reduce individual exposure duration, they do not reduce the overall noise level in the environment. This approach can lead to increased training needs, potential disruption of work schedules, and may not be feasible for all operations. It falls lower on the hierarchy of controls and is generally less effective than engineering solutions. Ethically, it shifts the burden of protection to work practices rather than directly mitigating the hazard. Finally, a purely cost-driven approach that selects the cheapest available noise mitigation option without a thorough assessment of its effectiveness or regulatory compliance would be professionally unacceptable. This approach prioritizes financial considerations over worker safety, which is a direct violation of occupational health and safety principles and regulations. It fails to consider the long-term costs associated with noise-induced hearing loss, such as workers' compensation claims and potential litigation. Professionals should employ a systematic decision-making process that begins with a thorough noise assessment to identify sources and levels of exposure. This assessment should then inform the selection of controls based on the hierarchy of controls, prioritizing engineering solutions. A cost-benefit analysis should be conducted, but it must weigh the cost of controls against the cost of inaction, e.g., hearing loss, regulatory fines. Regular monitoring and evaluation of the effectiveness of implemented controls are also essential to ensure ongoing compliance and worker protection. Question 19. Which approach would be most effective for a registered environmental, safety, and health manager to proactively identify and mitigate risks associated with musculoskeletal disorders, MSD, in a manufacturing setting, ensuring compliance with relevant occupational safety regulations? Option A. Focus solely on investigating MSD incidents after they occur to understand their root causes and implement corrective actions for those specific cases. Option B. Implement a series of standardized ergonomic equipment upgrades across all workstations without a prior assessment of specific task-related risks. Option C. Rely primarily on employee reports of discomfort and pain to identify potential MSD hazards and implement general ergonomic training for all staff. Option D. Conduct a comprehensive ergonomic risk assessment using validated tools like REHS or RULA to evaluate job tasks and identify high-risk postures and movements, followed by targeted intervention strategies. Correct answer is D. Conduct a comprehensive ergonomic risk assessment using validated tools like REHS or RULA to evaluate job tasks and identify high-risk postures and movements, followed by targeted intervention strategies. Explanation: scenario analysis. This scenario presents a common challenge for environmental, safety, and health managers, proactively identifying and mitigating risks associated with musculoskeletal disorders, MSD, in a dynamic work environment. The challenge lies in selecting the most effective and efficient assessment method that aligns with regulatory expectations and provides actionable data for prevention. A hasty or inappropriate choice of assessment can lead to wasted resources, ineffective interventions, and continued risk to employees, potentially resulting in regulatory noncompliance and increased incident rates. Correct approach analysis. The correct approach involves utilizing a recognized, validated risk assessment tool like REHS, Rapid Entire Body Assessment, or RULA, Rapid Upper Limb Assessment, to systematically evaluate job tasks for ergonomic risk factors. These tools are designed to analyze postures, movements, and forces that contribute to MSDs. Their strength lies in providing a structured, objective method for identifying high-risk activities, which then informs the development of targeted prevention strategies. Regulatory frameworks, such as those enforced by OSHA in the U.S., emphasize the employer's general duty to provide a safe workplace, which includes identifying and controlling recognized hazards like those leading to MSDs. Employing these validated tools demonstrates a commitment to a systematic, evidence-based approach to hazard identification and control, aligning with the spirit and often the letter of such regulations. Incorrect approach is analysis. An approach that relies solely on employee self-reporting without objective assessment is insufficient. While employee feedback is valuable, it can be subjective and may not capture all contributing ergonomic factors. This approach fails to meet the regulatory expectation of proactive hazard identification and control, as it is reactive and lacks the systematic evaluation required to pinpoint specific risk factors. Another incorrect approach is to implement generic, one-size-fits-all ergonomic interventions without a prior risk assessment. This is inefficient and ineffective because it doesn't address the specific hazards present in different job tasks. It represents a failure to conduct a proper hazard assessment, which is a fundamental requirement for effective safety management and regulatory compliance. Finally, focusing exclusively on post-incident investigations without a proactive assessment strategy is a reactive measure. While investigations are crucial for understanding the causes of specific injuries, they do not prevent future MSDs. Regulatory bodies expect employers to implement proactive programs to identify and control hazards before injuries occur. Professional reasoning. Professionals in this role must adopt a proactive and systematic approach to hazard identification and control. The decision-making process should involve 1. Understanding the regulatory landscape and its requirements for hazard assessment and control. 2. Selecting appropriate, validated tools and methodologies for risk assessment that are relevant to the specific work environment and potential hazards. 3. Using the data generated from assessments to develop targeted, evidence-based prevention strategies. 4. Regularly reviewing and updating assessments and interventions to ensure ongoing effectiveness. This structured approach ensures compliance, protects employee well-being, and optimizes resource allocation. Question 20. Strategic planning requires a proactive approach to managing chemical hazards. Imagine your company has recently acquired a new process that utilizes a chemical previously unknown to your organization. The supplier has provided a safety data sheet, SDS, but it is incomplete and lacks specific toxicological data relevant to your intended use. Employees have already begun working with this chemical. As the registered environmental safety and health manager, REHS/RS, what is the most ethically and regulatorily sound immediate course of action? Option A. Rely solely on the supplier's incomplete SDS and implement basic personal protective equipment, PPE, as a precautionary measure, deferring a full assessment until production demands lessen. Option B. Continue operations as usual while initiating a detailed hazard assessment and seeking additional information from the supplier, assuming the provided SDS is sufficient for initial safety protocols. Option C. Inform management of the potential risks, but proceed with operations as directed, emphasizing that the decision to continue is a business one, not an EHS one. Option D. Immediately halt all operations involving the uncharacterized chemical until a comprehensive hazard assessment is completed and appropriate control measures are implemented. The correct answer is D. Immediately halt all operations involving the uncharacterized chemical until a comprehensive hazard assessment is completed and appropriate control measures are implemented. Explanation. This scenario presents a professional challenge because it pits the immediate financial interests of a company against the long-term health and safety of its employees and the surrounding community, as well as potential regulatory noncompliance. The REHS/RS must exercise sound judgment to balance these competing demands ethically and legally. The correct approach involves prioritizing the health and safety of workers and the public by immediately halting operations involving the uncharacterized chemical until its hazards are fully understood and appropriate controls are implemented. This aligns with the fundamental ethical duty of an environmental, safety, and health professional to protect life and well-being. From a regulatory standpoint, this approach is mandated by the general duty clauses found in occupational safety and health regulations, e.g., OSHA General Duty Clause in the U.S., which require employers to provide a workplace free from recognized hazards. Furthermore, hazard communication standards, e.g., OSHA Hazard Communication Standard, require employers to identify and communicate the hazards of chemicals used in the workplace. Introducing an uncharacterized substance without proper assessment and communication inherently violates these principles. An incorrect approach would be to continue operations while initiating a hazard assessment, as this exposes employees to unknown risks. This demonstrates a failure to uphold the primary ethical responsibility to prevent harm and a direct violation of hazard communication and general duty provisions, which demand proactive hazard identification and control before exposure occurs. Another incorrect approach would be to rely solely on the supplier's limited information without independent verification or a thorough internal assessment. While supplier information is a starting point, the REHS/RS has a professional obligation to ensure the information is adequate and applicable to the specific use case, and to conduct their own risk assessment. This approach risks accepting incomplete or inaccurate data, leading to inadequate safety measures and potential regulatory noncompliance. Finally, delaying the assessment to avoid operational disruption prioritizes profit over safety, which is a severe ethical and regulatory failure. It demonstrates a disregard for employee well-being and a lack of commitment to a safe working environment, directly contravening the core principles of the REHS/RES profession. Professional decision-making in such situations requires a systematic risk management process. This involves 1. Hazard identification, recognizing the unknown nature of the chemical as a significant hazard. 2. Risk assessment, evaluating the potential severity and likelihood of harm from exposure. 3. Control measures, implementing immediate interim controls, e.g., isolation, enhanced ventilation, PPE, and developing a plan for permanent controls based on hazard characterization. 4. Communication, informing relevant personnel about the unknown hazard and the steps being taken. 5. Documentation, maintaining records of the assessment, controls, and communications. The REHS/RES must advocate for the necessary resources and time to conduct a thorough assessment, even if it causes temporary inconvenience.